Oh, sorry. And so within that ecosystem, we've been making choices on which platforms will survive, how products are being integrated, how all these decisions had to make that work. Part of that is what we call Healthsuite API management. And this is where also the area we'll be focusing on today. The Healthsuite API management is there to support an API-based integration between all these products. So in the picture, you can see here an application that may be built out of multiple microservices with internal data stores and queues, etc. That's not something that we're focusing on. We're focusing on basically the public APIs of those systems and how they integrate with other systems. So what we want to do within the Healthsuite API management is basically fourfold. On one hand, we want to standardize those integrations. And standardize on the APIs, standardize on the data models, standardize on the way they integrate the workflows, such that these systems do not directly become dependent on each other, but are leveraging standards which should help recompose and connect them flexibly. There's also a set of platform capabilities to help that integration. Think about authorization. Think about service discovery. Think about routing these calls, especially in hybrid cloud solutions, where some of these systems or platforms are on-premise and some of them are in the cloud. How would you connect them? And so some platform capabilities that come with this and to support that integration. Also, here's developer support, very important. I mean, to get developers and teams to integrate based on those standardized APIs and models and platforms, they need support. And the easier it is for the developers, the larger the adoption is. And so we support them in terms of documentation, but also conformance test specification. I mean, did you integrate that API in the right way? We can provide them with the test specifications so that they can run on their own. Similar with automation, so why if we're going to test anyway, I mean, why not automate those tests from the start and help these developers automate them by, for example, providing them the default set of test scripts for the different types of integrations. And the last part is having adapters. And not all systems will speak that language that we see in the middle, which we will talk a bit more about in the coming slides, natively. So we need interoperability systems basically that are able to map the languages and the variants of the languages that are out there based on HL7, V2, V3 or any custom API to that standards-based way that we want to integrate our systems. So from Philips it means it's following. So from where we come is that we had all these different products. And when they were being integrated, we saw all these peer-to-peer, basically direct integrations that were happening between them. And some of them are connected to each other, some of them to a third-party product. There's all kind of custom bits. And all of them are connecting on their own to a hospital EMR. That's not nice for Philips because there's a lot of repeated efforts, for example, in doing these integrations, but also not good for the customer experience because they have to set up that integration with their own EMR several times. Which is redundant work that you would like to avoid. So where we want to move to, or are moving to, is basically what we call the Healthsuite API, where we're standardizing on the data models. We're standardizing on how these interact in terms of workflows and what we call interaction patterns. We standardize on security, discovery, networking. It's all standards. With the idea that these products will not rely directly on each other, but just solely on the standards. In this model, adding a product D, that should become possible without changing product A, B, and C. And in the enterprise setting, that's pretty important because you're reducing the hard dependencies between the different teams and product groups that are working on this. And from a planning and dependency management and team collaboration efforts, that makes a big difference. It also allows specialization. Instead of all these products connecting to an EMR on their own, we can kind of factor that out into a separate layer, and in what we call the interoperability layer, where things like EMR adapters can be built that would translate to the hospital EMRs to that standardized model once, and such that these products would be able to use those, and we don't have to repeat that effort over and over and over again. And similarly holds for the third-party adapters. And information that comes out of that is something that can then be used by all the products that run. And in the end, we hope to reduce the number of integrations that need to be built significantly, and thereby reducing time to market and speeding up the integrations, and in the end, serving the customer faster and better. This is interoperability, and where we took a model of interoperability that we took from HIMSS. And so it's organized in 4 different layers. And we'll go over these layers and how we interpret them. On the foundational level, we see things like connectivity, TLS, security, OAuth, HTTPS type of things. Really the basic connectivity on how can these systems connect at all, and what kind of lower layer protocols are being used to connect them. And we see from interoperability perspective that already here you need to make agreements. For example, what versions of TLS are we using? Are we using API-based integration based on HTTP on REST protocols based on HTTPS, or are we doing something else? Are we using a binary thing, or there's choices to be made here. Similarly for the authentication pieces. I mean, are we using OAuth? Are we using SAML? Are we using any other protocol? The client certificates on TLS. If you don't make the right agreements here, the systems may be interoperable on the higher layers, but it still won't be able to connect and understand each other. Structurally is basically, well, how would you structure your interactions? That can be done in JSON, XML, FHIR resource formats are typically here, plus all DICOM, schemas, request formats. And this is already where you see things like FHIR play a role. Also, an open API is something that basically can be used to say, well, how is a specific request structured? And that's something that can be specified there. Semantically, also here, this is more about the structure of the data, but the meaning. This is where the FHIR resource definitions come into play, but in combination with terminology sets, DICOM, IODs, the SNOMED, LORING, FHIR. I mean, these are the places basically where these things are being specified. And we see typically in the FHIR community that this is the main area of attention. And this is where a lot of effort goes. Also in terms of tooling. Things like shorthand is focusing on this layer. In how would you profile the FHIR resources to meet certain use cases. And this is where you would standardize, okay, what is a heart rate? How do you encode that observation, etc. So this is where actually most of the focus comes. And then there's the organization. I mean, and we interpret that kind of as the workflow. I mean, given the semantics, for example, you have a patient resource. Sending out a patient resource to another system, what does that mean? What's the intent? Is the intent to have the demographics updated? Is it the intent to have that patient onboarded on a program? And so here there's a kind of workflows that are going on that basically indicate, yeah, well, which actors do exist? What type of transactions do they support to meet kind of common use case? And this is where we see a bit on FHIR, especially in the integration guides, but a bit more on that actually within IHE community. And this is where you see the integration profiles, like in the ITI frameworks, where more on a use case level, these things are being specified. To be interoperable, you need agreements on all these layers. If the agreements doesn't exist on one of these layers, interoperability will break. And that is also where we see that most of these standards, they focus on a certain section of the interoperability. And for example, in FHIR, there's very little said about the foundational levels. TLS is recommended, OAuth is recommended, but which exact OAuth scopes are to be used, for example, for the authorization, is not well specified. And also FHIR doesn't say a lot about the workflows and about how would you do patient referral to another system or another entity, or so there's a number of there's the core ingredients on the semantic and structure level, but how that really plays out in the overall workflows is not set there. But we need that level as well for the systems to understand each other. So how we see that? So how we see that interoperability is basically, and I'll take this by an example. In this example, there are basically 4 systems in play. It is a patient acuity stratifier, basically a system that can do risk analysis, and that's one of the former acquisitions there, Wellcentive, that brought in a system that's able to do that. So based on large patient population, that system was able to indicate, okay, which section of the population should be on a certain health program, doing that risk analysis. There are other systems, like the Vital Health system that it's also an acquisition, that is able to provide these patient programs. So Wellcentive was able to indicate, okay, these are the patients that should be in a program, but the actual program is delivered by another application. But before moving that, perhaps a questionnaire needs to be sent out to get extra information to improve the stratification, and based on that also improve the series of the people that need to go out. So we see here already 3 products basically from different origins that need to be integrated and to make the end-to-end solution work. And in there we saw a set of patterns. If you look at the communication lines, and for example, this is what we did in the red here, we see the referral flow. So basically one patient is transferred from one system to another. And it can be actually anything. It's now focused on programs, health programs, but it can be ordering a teleconsultation or requesting a taxi to bring someone to an hospital, or it can be that referral. It can basically be anything. And basically, it's kind of a service request, but you need to then be able to catalog those services, etc. So in here, it's kind of a referral pattern that we saw, and that was kind of repeating across a number of use cases. Similarly, for patient data exchange, I mean, how would you exchange patient data? I mean, after referral, typically the first thing in the next application would like to do is collect data about that patient that has been referred. And how would you do that? And also there we saw the consumers, our data stores that are able to provide that thing. There may be a data location index that basically is able to tell where data about a certain patient exists. And also this is a kind of repeating pattern. And that realization that to say, hey, on this level, these repeating patterns, we can standardize on them. So without really needing to know beforehand exactly what all these applications can do, we can standardize on how they interact in a flexible way. Mm-hmm. So in this ecosystem, when a new application comes and also has data to offer, when it's able to expose itself as one of these standardized data stores, others will be able to understand and retrieve data from there. So that's where we are starting to focus on, and these what we call these reusable interaction patterns. And those patterns need to work across these 4 layers of the specifications. So in here we specify the security pieces, the protocol pieces, the data models, as well as all the workflows. Across the whole stack, we're making the choices here. And that goes beyond typically what one of the individual standards does. And on top of that, based on that information, we have also a foundational platform support to support in the authorization. For example, we typically standardize an OAuth, but we also need a system that's able to work with that. And that's able to, where we can introspect these OAuth access tokens and get the right policies and these type of things. And this is where Hans will take over.
Yes. Thank you, Joost. I'll share my screen. Yes. Is my screen visible?
Yes.
Okay, good, great. Yeah, thank you, Joost. Let's dive a little bit deeper into those interaction patterns. Yeah, those interaction patterns are very much inspired by IHE profiles, and they also look like them, and you see a lot of different ingredients for that. For example, you see the actors. Let's see. Yes, I'm trying to find this one. Yes, you see the actors of the roles, which part they play, and those are also yeah, the actor definition. So the actor definition you see in the IHE profiles, you very often see referred here. Another part is, of course, the sequences. So the behavior that is expected. Yeah. So how does the actors interact to reach some goals, some use case? And there you see most of the time you use sequence diagrams, and one interaction can trigger another one. And also those transactions. The next ingredient is the transactions, and those are combined into APIs for the roles and different actors. So those are subsets of those sequences. So that's what so a sequence is a set of interactions. And what you see with those interactions is that very often that's a subset of the FHIR API. So you see there the FHIR API is very broad, but here you see that only certain arguments are allowed, or only a store is allowed, or a read of an update. So those transactions are very often subset of the FHIR APIs. I think that's an important part. But also you see here the things that defined like the security scopes, like Joost already said. Another part of the interaction patterns that we have are then actually the data models. So how does the data look like, and how is it formulated? And there, yeah, we most of the time used FHIR for that. So in there you see things like IGs and profiles. Well, this is an example of what we can then call our patient data exchange pattern. It's an interaction pattern, and you see several parts here. You see those bubbles, and those bubbles, they are the roles. So you see several roles here: a source role, a sync role, a store, a consumer, and they play a part in this pattern. We specify those specific external input and output behavior. Another part is the supported APIs. Those are uniquely named, and you see, for example, this one is an API on the role of the subscriber, where we also define the security scope here. Yeah, I think it's important to know that those APIs can work on the same resource definitions. So those source, this interactions, or this transaction and this transaction, they can use the same FHIR resource, for example, an observation. But this will be only a write, and this will be only a read of that observation. And then we also come to the specification of the FHIR API. Here we specified, so it only use the read of the write. Here we only use the read. So here you see that those transactions are actual real subsets of the FHIR API. Also here you see then those are the transactions that we already discussed, that the transactions between the different roles. Also what you can see here is that some roles are can be grouped because it's logic or mandatory to be together. You can see here a consumer and a subscriber. they can do the same thing. They want to have data, but on a different way. So that are two different roles, but it's very logic to have a grouping. That grouping can even be mandatory. But overall, the realization is that pattern creation is really a standardization effort, and requires alignment between several parts in your organization. For example, businesses, but also what we call the CAO. That's the Chief Architect Office. It's a central organization which makes sure that we have a unified, harmonized software architecture. This is one of the IHE profiles. What we see is that what we are doing is actually specializing the existing profiles, or specializing the IHE profiles. A bit like that we also do specializing with the FHIR profiles, which is called profiling. So here are actually what they're doing is profiling the IHE profiles. But there were a couple of things that in our point of view were missing in those IHE profiles. Things like authorization, the scopes. Are there additional resources needed to fulfill those profiles? Data subscription, data push. That are the things that then we added in our what we call interaction patterns. And also, I think what we try to do is we try to specialize the IHE profiles, but also when we do find things that we would like to add, or maybe even sometimes completely new profiles, we try to give them back to the community. So we're closely working together with IHE to Philips is a part of that, so to bring in new profiles or to make changes to profiles that are still under consideration. But if we dive deeper a little bit on how those interaction patterns look like, what are the parts of it? What we have is we have there an introduction, that shows which use cases are those interaction pattern should fulfill. Of course, who created them, the author, but also the adopters. We like to keep track of who adopted, and of course the version. And then if you look more at the profile itself, we mentioned the standards that are used, which are based on which IHE profile is based, and also which FHIR profiles are used for the data contracts, and also the FHIR IGs. You see there, of course, an overview of which roles of actors there are, the dependency between those roles, use case realization flows, sequence diagrams, and so. And when you look at the transactions, you see there the more like the real API specs. You see that based on Swagger API, on Open API and Swagger, and of course the OAuth scopes, and also we also thought it was really important not just to talk about the happy flows, but also about the error handling. When does which error occurs, and how to deal with that. And also what we find was that for adoption, it's really important to have developer support. You cannot just put those specifications on a central website and say, have fun with it. No, you really should support your developers. I can only say without developer support, adoption will be really hard. And something that we currently really are working on is the test support. We want to have automating test scripts. We want to have test cases and test specifications, for example, for the data. So we could really see that everything works, also when changes are done as planned. What do we mean with specification as code? We use the GitHub workflow. So all our patterns are in GitHub. Also, all our FHIR profiles are in GitHub. That means that within Philips it's open to everyone. So everyone can look at it. Everyone can clone the archive. Everyone can see the discussions. Also, everyone can bring in new issues. So if for example people have an ID for a new pattern or a new FHIR profile, they can add it. And for development, we use the GitHub workflow. So we create feature branches, we create pull requests, we use the milestones, we use the reviews, and also we use the pull requests really as a discussion format. So within our pull requests, we really can have the discussions on certain parts of our patterns. When you look at the patterns in the repository, you see that our documentation is very much IHE style. You see that Open API specification, YAML, There's a configuration file to support build pipelines and system configuration. And also, as I said, we're currently working on our test protocols for the automated testing. And of course, we also have our build pipelines for the automatic publication, verification, the releasing, updating of our internal registry, and our automated publication of our API management platform. Well, if we dive a little bit deeper on that, if you look at, for example, this is our GitHub, you see there are certain areas. Our central part or our beginning part is the issues. If people have an ID for a new pattern, they can just submit it. And there's a nice green button here. And then, that of course comes under consideration. Then when we start development, we almost immediately start with a pull request. So we can use that pull request as a format for discussion. So you can also see the whole discussion of why and how something should be organized, should be done. In here, if you look at if you look at how we store our interaction patterns or our IHE-like profiles in our repository, you see several parts. This is our folder structure. There's a name. There are the set of API definitions, YAML file. You see our documentation, our IHE-like documentation. Those are the use cases, the profiles. And here you see the description of the transactions and a piece of generic documentation in the form of a README. If you dive into pattern.json file, that's a bit of a special one. That one is really for our internal configuration and for our platform API management component. And there you see things like who created this profile, the authors, but you also see the roles and which transactions. And that is also used in verification and also used in the authorization. So if it's not specified, if the transaction and the roles are not specified in this file, those transactions are not allowed by our platform component. And if you look in our documentation is, like I said, IHE style. It's all in Markdown. We use PlantUML for our internal PlantUML actually for our pictures. But you also see, you can insert pictures yourself, and you don't need to do it with PlantUML, which is convenient, but you don't need to do that. You can also add your own custom images. This is one of our open API definitions of one of our transactions. And here you see what I meant with specialization of the FHIR API. This is a search. Within that search, we have a response and we say, well, this should return a bundle, always. You also see it's in FHIR 4. We define our security scopes, or 2 scopes. And also we define our error codes. For example, a 400 and a 401. And those are detailed out in those sections, which we didn't fit in the picture. And also we specified how the bundle should look like. This is a FHIR bundle, but we wanted to give it more detail, so we specified it in this part. So I think important this sheet is to see that it's really a specialization of the FHIR API, what you use. It's not something completely new that we invented in Philips. It's a specialization of what's something that's already there. But then of course we have created all those nice interaction patterns, but then of course we wanted to share them with the rest of Philips. For that we publish them. We publish them in an npm package format, and we do that on a central location within our organization. Here you see all our release patterns that we have. So that is in the form of npm package. So everyone with Node can do npm install and just get the pattern to their system. But we also created a special one, that is this one, and that's kind of an umbrella package. If you do npm install on this one, if you install this package, then you will get all of those other ones, because they're dependent on it. That's of course easy for testing and easy if you want to play around with it and to look what's already there and have examples. You can, with one simple command, get everything on your local machine. Now something of our documentation. Our documentation is always all stored on GitHub pages. You see several things here. you see a complete list of all the interaction patterns that we have currently released. You see a piece of generic introduction of what actually we are doing here, what this is, and also our processes. So we're very transparent in what we do and how we do it. So if you want to contribute to it, you can just open this link and you see exactly how to do that. Also how we do our development, how actually we're dealing with incoming use cases, and our complete release and deploy procedure. If we dive in one of the patterns, this is the federated data exchange patterns, and this one. This one, sorry. You see here that in the documentation we have the use cases. That's on this right panel. We have the use case generic description, and we have detailed out all the use cases that this interaction pattern does cover. We also described the transactions, and we described in detail the APIs in the Swagger format, and it also has a Swagger view in this documentation. And this is also accessible to everyone within Philips, of course. Then we come to the end, and well, what exactly did we cover? We cover that interoperability should really be done end-to-end across the stack, because it covers all those parts, and yeah, you need to cover them to do the interoperability. So the organizational, the semantical, structural, and the foundational. And we try and we want to use the base standards as much as possible, but we see that yeah, those cover only a portion of what we actually need for the interoperability, and then sometimes they are really broad, and we need to specialize them to only show the parts that we actually want to use. But we do use external standards, and we make choices on the specialization across the complete stack. And we try to bring those innovations back to the public standards. So Philips is part in IHE and is part in the FHIR standardization, and we try to bring those innovations back to the standard. I think that's important. Yeah, we do use an inner source process to standardize those interaction patterns. Therefore, it's community-based. You cannot do this alone in a small part of the organization. You really need to do this in a larger community. Yeah, we try to one of the next steps is now to do automation and verification and publication. Publication we already have, but verification we're now currently working on. Yeah, our last finding that we had was that developer support is really key for adoption. You really need to support your developers. It's support and then in the form of code generation, test automation, platform support, for authorization discovery. That really helps. If it's easy to develop for, then the adoption is much easier to achieve. Yeah, during those dev days and also after dev days, you can always contact us. These are our email address. Via the Wova app, you can also contact us, but you also, of course, are free to contact us by mail. I think this is the end of the presentation. I think now time for Q&A.
Thank you, Hans. And thank you, Joost. We have one question on the Wova at the moment, and that is, will you use the FHIR test script resources for automated testing in the near future?
To be honest, I don't know yet. It's not something that we have currently actively looked at, but it is an interesting suggestion that's for us to pick up.
Yes. Yeah. It's definitely something to look at.
Yeah. We're currently doing code generation, for example, based on the OP and API specifications, and also using a lot of the more standard REST tooling, like Katana and these kind of things to automate the tests. But yeah, it's an interesting suggestion for us to have a look at.
Definitely.
Okay, no further questions on the Wova. Do you have? Oh, we have one question in the room, so I'll just walk over there.
I assume many of the products you have already similar functionality in the implementation, which is now defined in a more common way, how easy it is it for you to convince these existing products to change, to migrate to this more common way of doing things?
Yeah, well, always has to be a good reason to do so. I mean, changing to this way is effort, is money, is time. So what we see is basically that we take this from a solution point of view, and take a solution that you would like to bring to the markets. So typically it starts actually with the market, that it sees an opportunity in which they can sell a combination of products. And basically it's then working backwards from there, saying, okay, how, given those solutions, how do they need to integrate? And as more of these come in, people do also, the businesses recognize, well, it makes sense to avoid the repeated integrations by moving to these IHE API way of working. And so that's typically how we approach it, taking from specific market use cases and then bring it back to say, okay, then how do you integrate across to support such use cases? Because then immediately, they need to integrate anyway, and then better do it then in the standardized way and avoid future repeating work. So this is basically the story that we tell, and that's also where we see where it is picked up. So basically working from a market opportunity backwards to the individual businesses. And because just going there to the business and you have to, that's a hard sell, to be honest.
Challenging.
Yeah, because they already have something, and why would they invest in this instead of something else? You need to make that opportunity clear, and that basically comes with a market opportunity.
Yeah.
Okay, thank you. I think that brings us to the end of our time and this presentation. Thank you so much, and have a good rest of your day.
Thank you.